is. Boom. Hey, students of Seneca, welcome to the GCSE Physics Paper 1 HyperStream. Gong is here.
Gong gang.
Gong gang. For anyone that was in the GCSE Spanish HyperStream a bit earlier, or the ones yesterday, you know the gong. We are the gong gang. We are ready to go. I'm here with Tom. Tom, say hey.
Hey, how's it going?
Tom is a physics legend. That is the best way to describe it. He did physics at Oxford, right?
I did.
See?
Legend's a strong word, though.
I don't know. So he is our mastermind. He's going to help us in this live stream. Thank you for all of the questions you've been shouting in and letting us know. We had loads of requests for radiation. So we're going to go over some 1 and 2 markers for radiation. Tom, are you ready?
So hyped.
So hyped.
So much hype.
Alpha, beta, gamma, it's all going down. And we've got some requests for latent heat and specific heat capacity. So we're going to go over an exam question for that. And it's going to be wild. It's going to be great. El gong es magnifico. Thank you. It is. The gong is great. It's so much fun. Every time you guys get an answer right, we'll hit the gong. And we're going to get in trouble with our office manager. But it's worth it.
Fine. You can't hear it that much.
Okay, can you not? Okay, good. That was my next. I don't know how loud it is. It sounds really loud in here. And I'm just really worried it's loud out there. Okay, electricity. We'll see if we have time. Gong, gong, gong. So we're going to start with just some good tips for the exam. So for GCSE Physics, I would say always make sure you give enough detail in your answers. Important, right, Tom? Yeah. So if it's a 3-mark question, how many points do you think you need to give?
Probably 3 different points.
3 different points. Don't make the same point twice. You want to make 3 separate points. That's what's going to help you get those 3 marks.
Yeah.
Okay. And if you're drawing diagrams, make sure you use ruler and label with straight lines.
It's a nightmare otherwise.
Exactly. And you want it to make it as easy as possible for the examiner to give you those marks. Especially when you're drawing graphs, use straight lines and remember to label the axes. Always, always remember. Another thing that's important with physics and all the science GCSEs is to use specific scientific vocabulary.
Better than that thingy. Or
yeah, exactly. We don't want thingy. We don't want that kind of weird thing. No, you've got to be specific with your language because the mark scheme have underlined words. Those examiners are cruel people. They underline words on the mark scheme, and if you don't use that word, you don't get the mark. So stuff like, don't say movement energy. We're going to say kinetic energy. Easy. Like for gravity, potential energy. Yeah. You want to be using those keywords to make sure you get those marks. So that's just a good thing to look out for. Now, physics, we've also got a lot of calculations, don't we?
Yeah, a lot of equations.
Lots of equations, heavy. Adjectives are hard sometimes. So, like with anything, make sure you show you're working. It sounds so simple, but so many people forget. Show you're working, right? Yeah. And I would say, like, when you have an equation question, just write the equation you need to use at the top of the answer, because sometimes that can give you a mark, just writing the equation you need to use.
Easy marks.
Easy marks. So always write the equation you're going to use at the top of your answer. So if it's kinetic energy, it's like Ke equals half mv squared. So put that at the top, boom, you've probably got a mark, okay? And then it's also really easy to like label the different parts you need. You need M, you need V, so you can find that in the question. Great. Another thing to remember with calculation questions is units, right? Yeah. Super important. Don't forget the units in your answer. That can sometimes, and also if you don't know the answer, just also write the units in the box. Because just like in GCSE maths, that can give you a point, just putting the right units in the box.
And if it's a multi-part question and you can do the second part but not the first, always just rewriting an answer to the first part, because sometimes you'll get a carry-through mark as well.
Oh, that is a gong-worthy tip from Tom. Bam!
I got gonged.
You got gonged. Amazing. So yeah, you can get this thing called error carried forward. Whereas if you know how to do the second part of the question but can't do the first, pick any number you want for the first one.
Make it an easy one. Make it 1.
Make it 1. Make it 1. And then do the second part of the question, and you will get yourself a nice little mark. Top tip from Tom. Thanks,
you got my name, didn't you?
I didn't. I was trying to read the comments as well. I knew your name is Tom, but like multitasking is hard. But I think it's going okay. So keep all your questions coming in. Required practicals will be going over specific heat capacity, so you've got that to look forward to. I'm glad you enjoyed geography yesterday. How did the exam go? I hope it was well. I'll stop talking about other ones now. So, okay, I'm just gonna share my screen with you guys because we're gonna go over some heavily requested radiation 1 and 2 markers. Tom, are you ready?
So ready.
Tom, are you steady?
Okay, I am ready.
I was gonna say, it's kind of, the gong is putting me on edge. So it's just like every time it goes, it's like a little shock, but I like it. It's keeping me awake. Okay, so we've got that. You'll see our faces in a tickety boom. There's always a little countdown. We need to get better at doing this, but I kind of like the drama. Share. So you'll see us. Oh my God, we're gonna be back real soon. There we are. Look at that. Ah, so cute. So we are going over some radiation 1 and 2 markers, and we'll be going over some key radiation terminology as we go. And these are the kind of words we're going to be going over, are those ones that you need to use to get those marks in that exam. Okay, so gamma radiation, this was heavily requested. That's used to treat conditions such as cancers, and they can penetrate the body to kill cells internally. Now, gamma radiation is a wave, not a particle. Remember, important. Yeah. So why is gamma really reasonably safe to use? Well, gamma has a high penetrating power, okay? Penetrating power. So that means, what does that mean?
It means that it's going to go through everything.
Boom, it can go through anything, okay? So that's what you want to remember about gamma. Gamma is the most penetrating radiation out of the 3, yes? But it's the least damaging. So it will pass through most of the healthy cells without ionizing them. So that's one of those key words we want to use. Ionize, create something charged, okay? So that's why gamma is reasonably safe to use. What's the most damaging radiation? Shout out on the chat. What do we know? What causes the most damage? You'll get a gong if you get it. Which is the most damaging radiation? We're waiting. Otherwise, I'm gonna have to gong myself if we don't know the answer. So the most damaging, yes, Linus. I hope I'm saying that right. Boom, alpha, really good. And a good tip to remember for radiation. Oh, you're all flying in with alpha. Yes. Gongs. So good. We are gonna get in trouble.
I didn't get the gong. My gong next.
Oh my God. Okay, Tom's. I feel I'm holding the gong. Yeah, really good. And a good point to remember is that for the penetrative power and the damage, they go in opposite directions. So alpha is the most damaging but the least penetrating. Then beta's in the middle, it's chilling, having a good time. And then gamma's at the bottom as the least damaging but the most penetrative. Hard word to say, penetrative. Yeah. Okay, so why would alpha radiation never be used for this purpose? So it's not penetrative. That's what we've just said. Alpha is not penetrative. And it can be stopped by a few centimeters of air. So alpha, it can't even get through air. Can't even get here. If this was alpha radiation, it could not get through the gong. It could not get through the gong. Nice, Tom. And it will never make it to the body. So we couldn't use alpha for chemotherapy, okay? But what is a suitable use for alpha radiation? Do you know? Shout out on the chat. Which one of these is going to be the best one for alpha, considering that it is stopped by air? What's going to be useful? A useful use of, oh, I'm getting excited.
Get some pigeon going.
Yeah, that was the pigeon noise. I try to do an owl, but I'm not very good. So I sound more like a pigeon. Smoke detector. Yeah, oh my God, straight in there. Linus again first. That was a gong. That was a loud gong. My ears gonna be ringing.
Gong be ringing.
Gong, what? What was that word? I liked it.
Ears gong be ringing.
Gong be ringing. That was nice. That was good. He just said what I said, but I didn't hear him. Smoke detector, really good. Because when that alpha radiation is stopped by air, it sends a alarm message. That's the technical way of saying it. And then you get all that BP stuff happening with the smoke detector.
Exactly like that.
Exactly like that. Okay, so what is an alpha particle made out of? So I always remember it's a type of nucleus. It's a helium nucleus. Yeah. And a helium nucleus has 4 things in it, but 2 of each.
Yeah.
Right?
Perfect.
So what have we got, Tom?
So we've got 2 protons.
Yeah, we do.
And we've got 2 neutrons.
Hell yeah, we do. 2 protons, 2 neutrons. Helium nucleus. You guys are so good. Shouting out on the chat. Let's give a soft gong. That was cute. That was a nice little soft gong. So 2 protons, 2 neutrons. That's what we've got in an alpha particle. Okay. What's a beta particle? We haven't talked about beta. Shout out on the chat. What's a beta particle made out of?
It's a fast-moving electron.
Oh my god, so fast. Yeah. Bam. So beta, fast-moving electron. Really, really good. Okay, so 2 common sources of background radiation. Radiation is everywhere. Everywhere. This is not a conspiracy. It's coming for us. Can you hear it? Oh, that's what it sounds like.
The radiation coming for you.
It doesn't sound like a pigeon.
The pigeons are not the source
of
of background radiation.
Oh my god, fast-moving electron is beta. So, background radiation, some common sources. So, I think it's going to be nuclear weapons and cosmic rays. How about you?
Yeah.
I think it is. TVs no.
TVs no.
You shouldn't watch too much of it, but now we've got our laptops and our iPads. Times are changing.
So much radiation.
Much radiation.
But it's fine.
But
it's not from those.
It's not from those. Not microwave ovens, they do have a type of radiation, but that's infrared. Isn't it? No, that's an oven.
Yeah, but
microwaves. Does it? Yeah, it does. I'm gonna say
microwaves use microwaves.
That's it. They use microwaves. See, you're welcome for the wisdom that we're imparting. Thanks. Thank you. What's the unit of radiation dosage? It's like this. Yeah.
I was going to say Curies, but it's been a while since I've studied it, so I'm not sure if that's right.
So I
made a classic mistake.
I can't spell it.
Oh, Sievert.
I think it's Soviet. Sievert. That's the unit of radiation dosage. Sievert. I can say it. I always say things the way you write it. So I say Sievert because then I know that's how you write it.
Nice.
You're all welcome. Okay, so when measuring the count rate of a radioactive source, a higher count rate may be expected, may be detected. Rhyming words should not exist on a paper. That was hard. So what could have happened? Well, the background count can also be included in the measurement. So that's why when you measure the radiation of something, you've always got to take into account that background radiation because it's always there. We got our cosmic rays, we got our nuclear weapons, boom, boom, boom. Really good answers coming into the chat. You guys are killing it. So we take an independent measurement of the background count rate, and then we subtract that count from each measurement. And that's how,
we got a memory.
We got a memory. Where
are we going?
Where should we go?
They can't see the memory.
Can they not see the No, there's a little lag. There's a little lag on the camera. Guys, where should we go? Should we go to I can't say that. See,
Mystery Island or
Mystery Island or Switzerland. Where should we go? Which you pick for us? Come on. That's right. Radiation does vary. Love that. Yeah. Where are we? No one wants to pick. Switzerland. Switzerland it is. Very good. Oh my God, so many people want Switzerland. Love that. So Gstaad, we've got a nice little memory. Love that. Okay, so next we are going to go over. So super requested was, let me see if this works, a specific heat capacity stuff. The best. So we're going to go over specific heat capacity. Okay, it did switch. Perfect. Specific heat capacity, and what we're doing, we're also going to talk about latent heat. Oh, let's quickly talk about what a half-life is, though. Half-life is the time it takes for a radioactive substance to decay by half, okay?
So if you have 1 kilogram of this substance, the half-life is the amount of time that it takes till you have half a kilogram.
Okay.
Because basically, like, when they decay, it's like random probability, so you have to take an average over a large number of particles when you do it.
Okay, good. See, top tip from the physics mastermind. Oh, I don't know what that was.
There's a pigeon coming.
But I don't know. I think there's a pigeon in here. This room is also so warm.
It's also really bright when you look up.
It's a lot. We got downgraded from yesterday's room. I don't know what happened. Start a petition for us to get a better room. Please.
We want to see the petition in the links.
Yeah, petition for us to get a better room. And maybe some better microphones and cameras.
And maybe a bigger gong.
Yeah, let's do it. So, okay. Half-life, time taken to decay by half, and it's always, normally if you have to calculate it in a question, they normally give you like seconds or minutes. So if it goes down, if the half-life is 8 seconds and we have 1 kg, in 16 seconds we'll go down to half a kg and then a quarter of a kg, 250 grams. So whatever the time is, that is how much it goes down by half. I think that made sense and cleared stuff up. Next, we're going over some specific heat capacity questions. So we have an unknown liquid, which has been found in the lab, and it's characterized by its thermal properties. The lab technicians have decided to find the liquid-specific heat capacity. So, super fun. What is the specific heat capacity? So this is a key definition, and it comes up a lot in it's a very key definition question.
Yeah, it's just one that always comes up in the exams. It's one that's good to know.
So it is the amount of energy required to raise the temperature of how much, Tom?
So 1 kilogram?
I think it's 1 kg by 1 degrees Celsius. So easy to remember because it's energy 1 kg and 1 degree Celsius, okay? So the lab technicians intend to heat the liquid in an insulated container and measure the amount of energy used as the temperature rises. So why should the container be insulated? So this is an experimental technique question. It's one of your assessment objectives. So
lots of shouts
for 1 kg. Guys, awesome. That's really, really good. You guys, you know your definitions. You should be feeling so confident and prepared for tomorrow. Like, well done. Super, super impressed. So why is that container insulated? Well, experimental technique. Which answer is right? Let us know. Yeah, to keep heating, really, really good. So another way of saying to keep heating is to make sure that it's not lost to the surroundings, okay?
Nice.
So really good job. That's a nice gong-worthy bam. Really, really good. I think we're getting better at the how loud the gong should be. We're getting there.
We'll get a big gong going on later, but can't have too many.
Exactly. Maybe if we get a bigger room, we'll get a bigger gong. The possibilities are endless.
That's why you need that petition.
Yeah, exactly. So
everyone else throwing out answer 3 as well. Good job.
Very good. You guys, awesome. So what equation is used for determining the specific heat capacity? So key equation, we had lots of requests for equations. This is one you need to remember. Very good, straight in there with MCT, really, really good. So it is the change in energy is the mass times by the specific heat capacity times by the temperature change. That cute little triangle, that means change. Yeah. Yep. I think it's delta, right?
Yeah, it's capital delta.
Capital delta. So I would say things to remember, that mass is always it's a mass, so it's not different to a weight. So mass is always in grams, kgs, whereas weight is in newtons.
Yeah.
So another thing that lots of students mix up. So we find out that 40 kilojoules of energy is sufficient to raise the temperature of 1 kg of the liquid by 10 degrees Celsius. So what is the specific heat capacity? Well, let's remember our equation. So MC delta, and specific heat capacity is on paper, it's on paper 1, for those of you who are asking. So you need to know it for tomorrow. So luckily, we're going over it.
Perfect timing.
So we want to rearrange the equation. And again, a tip I would say when you're working this out is just write out the full equation again and rearrange it step by step. Because in the exam, it's really easy to make silly mistakes in the heat of the moment, right?
Heat of the moment, like it.
No, that wasn't intentional. That was so good. In the specific heat of the moment. It can be.
You've gone too far.
Too far? Okay, I did. I should have quit while I was ahead. But I had a good time. Okay, so anyone know what we need to enter here? So this is a good tip. So we're told it's 40 kilojoules. For this equation, we need to keep it in joules. And to go from kilojoules to joules, we times by 1,000. So 40 kilojoules is 40,000 joules. Now we've rearranged our equation. We know our mass is going to be 1 because it's in kgs.
Yeah.
And we've got to times it by that temperature change, which was 10. So the specific capacity is going to be 40,000 divided by 10, so 4,000 joules per kg per K. That's a lot to say. Yeah. So we've got 4,000 joules per kilojoule K. Really, really good. Loads of you are shouting that out on the live chat. So really good. You guys are doing great. You're doing fine. So using your answer from 6.4 in the table below, what is the liquid likely to be? So we know that we got it as 4,000. So all we have to do is pick the one that's closest to 4,000.
Yeah.
Seems like a good idea, Tom, right?
Yeah, it probably is.
Probably is. So are we going to go for ammonia? I don't think we are, because there's something closer. Yeah. What is it?
Well, it is water.
Water, really good. So water, 4.180, that is a specific heat capacity. So it's going to be water. So while we're talking about specific heat capacity, a lot of people requested, really good, water. Gong, 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 gong.
You're going for a big gong?
We'll end with a big gong. You'll have that to look forward to. Nice, cute little gong. That was it. We're going to talk about specific latent heat. Sorry about the pigeon noise. Guys, it's a thinking noise. I'll try and like tune it out. So specific latent heat. Now, a lot of people can confuse the difference between specific heat capacity and specific latent heat. Now, the key thing with specific heat capacity, the temperature's rising. Yeah. Okay. Whereas with specific latent heat, the temperature's staying the same, but we're changing state. So we're going from like a solid to a liquid.
Or liquid to gas.
Or liquid to gas. It could be either.
Or the other way around as well.
Yeah, we could be going from a gas to a liquid. Boom. So latent heat, the key thing with latent heat is the state change. And if you're pushing for like 7 to 9 in terms of what's happening there, we're breaking the bonds. That's where the energy is being used. So when we're changing state, we have to break the bonds in the molecule, and that requires energy. So that's where that energy is going. So good thing to know if you're pushing higher. But other than that, just remember latent heat, changing state, specific heat capacity is when we're just increasing by 1 degree for 1 kg. Boom.
Boom.
Really, really good. Okay, nice gong. Okay, breaking the bonds when changing state. Really good. Remember that. Remember that.
Go on, Rose. Remember.
Rose, you got this. So that was a very quick run through of specific heat capacity. I think we should do a little stress buster. What do you think? Because we're getting towards the end of the live stream.
Well, actually, before that, one last exam tip then before we...
Oh, another exam tip? I'm so ready. Let's go.
So one I got when I was at university was always have a quick read through the paper first and find the easy questions.
Okay.
Do those ones first, because that way you get the confidence boost of you've done the easy marks, so you know you're guaranteed to get like a minimum amount. If you're struggling with a question, just move on, leave it behind, come back to that at the end.
Yeah.
That way you're not spending forever getting stuck on one bit when you could actually have finished the rest of the paper.
That is a good that's a really good tip. That's a good pearl of wisdom.
Works for every exam as well, not just physics, guys.
I'm going to say it. That would have helped me out a lot, because sometimes you get like a corker 6 marker, like question 1 part E, and I'm like,
and you're just there for ages, like, what am I doing?
Yeah.
Words.
And then but sometimes also you have a bit more time to think about it. You can come back to it later. So
stroke of genius later on.
Boom, exactly.
Write it down.
Really, really good. Thanks. That was a really good tip. Thank you.
You can use it on your other.
I was going to say, I consider that one stolen. But I will credit you. But okay, so stress buster. We're going through the koala guide, really cute, to exam stress, because GCSE is a stressful time. So it's important to keep things in perspective and to keep mentally and physically fit too. Yeah. Tom, you had a point.
I was just going to say, yes, this live stream does finish at 6, guys. Because I can see a few people asking.
It does finish at 6. And I think something else is happening at 6 o'clock too. Something like a free trial of Smart Learning. So if you guys want to try out Smart Learning, which uses like data and like suggestions to make learning more efficient, free trial at 6 o'clock on the Seneca website after this. So give that a go if you want to.
Give it a go.
Yeah, it's really cool. I use it. I use it on my account.
Plus, you get a really cool theme. It goes all blue.
What?
Looks
sick. The theme does look really, really good. I quite like purple though. But yeah, so stick around. There's a Smart Learning trial at 6 if you want to have a go at that. So, top tips for exam stress during this period: eat healthily. Really important. You want to feel your body, feel your mind. Your brain's working really hard, so you want to have your nutrition on point. Maybe have some quinoa, some avocado on toast. So good, so good.
Saying all the right food words.
I used to eat so much oatmeal during exams, and I would make some overnight oats. So like you soak them the night before. You can like microwave them in the morning.
You getting some peanut butter in there?
Oh, see, I knew it said that. Every day, Tom has peanut butter and oats. and it makes the office smell so
A
good.
little bit of chocolate as well.
You put chocolate in there?
Yeah.
When did that start? Okay.
Been doing it since before you arrived.
Oh my gosh, I didn't smell the chocolate. That is a delight. So nice, healthy peanut butter oatmeal. You can call, with a bit of chocolate in it. Call it
Dark chocolate. It's good for you.
Good for you. Full of riboflavins or something, I think.
Yeah, that sounds about right.
But call it the Tom oatmeal. Peanut butter, dark chocolate, oatmeal. Delicious.
I'm going to stir fry today. That's pretty healthy.
That's really good. You are fueling your brain. Get enough sleep. Sleep is so important. And I'll tell you why. Sleep is where you consolidate your memories. So that's when memory goes from your short-term into your long-term store. That's when you're having a nice little sleep. So make sure you're getting enough sleep during your exam season.
Make sure you're sleeping well. So don't, like, just before you go to bed, try and put your phone down, get away from the screen for a little bit.
Yeah, exactly. And also peanut butter is delicious, Hugo. I thought we were becoming friends. It's so good.
Hugo.
It's so good. I'm kidding. It's not for everyone. I love peanut butter. I buy it by the kg.
Yeah, I've almost finished my kg now.
What are you going to do? What are you going to do when it's done?
Get another one.
Okay, that makes sense. So yes, get enough sleep. That's where we consolidate all our memories. Okay, so take some time out for yourself. Really important. Self-care. Maybe go for a nice walk. Maybe just read 10 minutes of your favorite book. Something like that. Just a little bit of time for yourself because you're probably working really hard. So it's okay to take a bit of a break and some time out.
Yeah.
Then another top tip, hang out with your friends, see your mates. You don't need to apologize, Hugo. You like what you like. Hang out with your mates, see your friends, talk to your friends if you're feeling a bit stressed. Always good to talk about these things.
Nice to just take your mind off it for a little while as well.
Exactly.
You just don't want to get stuck in that. I'm stressed.
Exactly.
Think you're stressed.
Exactly. It just becomes a cycle. So talk to your friends, all good. Such a cute gift. And we got you. You're going to be fine. You're going to go into that exam and kill it. So everybody, thank you so much for joining and the best of luck for the exam tomorrow. I hope you guys feel confident, feel ready to go. I'll stop the screen share now.
A big old gong, or we got more to say?
When we say goodbye. So good luck for the exam tomorrow. Remember those tips. Always put your units, show you're working. Don't leave anything blank. Always try and have a go. Stick around for the Smart Learning trial. So head on over to the Seneca website to try that out. We've got some more live streams coming up this week. So we've got GCSE Business where Stephen, who's in the Spanish stream, will be back.
Stephen was loving it.
It's gonna be wild. So make sure you hit subscribe to keep up on all the updates so you know what's coming. And let us know what live streams you want to see. I know it's half term next week, but after that we'll be back with more top tips and last minute revision for the exam. Thank you so much for joining us.
Thanks,
it's been a lot of fun, and thanks for getting involved and answering the questions. It makes this a lot more fun and useful for all of us. So that's really, really great. And we've got one final gong to see us off, and see you tomorrow.
Bye, guys.